The distributive property states that a multiplication fact can be broken into smaller multiplication facts, which can then be added up, all to make an easier problem to solve. For example, if we're trying to solve 9 times 6, we know that means 9 groups of 6, or 9 sixes. We can use an array to help us solve this problem. We know 9 groups of 6 can be represented by 9 rows of 6. So we can actually take those 9 rows or 9 groups and break them into smaller chunks. So we can have 5 rows of 6 and 4 rows of 6. We know 5 groups of 6 is 30 because our scholars can use the commutative property. It can be 5 sixes or 6 fives. 5, 10, 15, 20, 25, 30. We know 4 times 6 is 24 because our scholars know how to skip count by 4s. 4, 8, 12, 16, 20. 24. So now we find the sum of the products of our smaller facts, which were 5 times 6 and 4 times 6. So we figured out that 5 times 6 was equal to 30, and 4 times 6 was equal to 24. So now we know that 9 times 6, or our entire array, is going to be equal to 30 plus 24, which is easy for our scholars to mentally add, just adding 3 tens to the 2 tens to make 54. So that's how our scholars know 9 times 6 is equal to 54, or there are 54 total. Now you might be thinking, well, why can't they just memorize 9 times 6 equals 54 just to save them all that trouble? Why make it more confusing and more complicated by doing all those steps? Well, this property is really important to practice with smaller, easier problems because it will eventually help our scholars solve much more difficult multiplication facts. We know it is impossible for any normal human being to memorize every possible multiplication fact, like these 3 examples. So our scholars need to be able to solve multiplication facts quickly in their heads without always relying on pencil and paper or a calculator. They're going to have to know how to break problems apart to make easier problems for mental math. For example, and this is not something our scholars are going to be expected to do by the end of this year. This is just, in later grades how this skill is going to be built upon. So if we're trying to solve 31 times 3, students aren't just going to know that fact, off the top of their heads. But if they know that 31 groups can be broken into 10, 10, 10, and 1, because 30 is 3 tens, and then you have the 1 group, we can then figure out the product by doing 10 times 3, which they know is 10 threes or 3 tens, 10, 20, 30. So they know 10 times 3 is 30. 10 times 3 is 30, 10 times 3 is 30. So it's 30 plus 30 plus 30, and then one more group of 3, which is 3. Then they can mentally add these 3 groups of 3 tens, which equals 90, plus 3, which would then equal 93. So as you can see, the distributive property seems like a lot of steps, seems pretty complicated, but it's actually going to be really important for our scholars to be really efficient with math, and especially mental math, solving these multiplication problems in their head. Here's just another way to represent that same problem that we just worked on. We started with 9 times 6. We broke it into 5 times 6 and 4 times 6. Just another way to represent that is by breaking the first factor, the number of groups, apart. We know 9 can be broken into 5 and 4, and then we are multiplying each of those by 6. And that's the distributive property.